Hi, Math 20s. Welcome to the first online lesson for our statistics unit. So in your booklets, it's the page that says standard deviation at the top. It should be the next after what we had finished last class. So I'll work on here. If at some point I ask a question or I want you to go through it, just pause it and try it on your own sheet. I'm not going to sit and wait for 5 minutes, so just pause it. See what you can come up with this for a solution, and then restart the video and see where you got. So let me click on here. So as we talked about in class the other day, we talked about measures of central tendencies. So the ones that we used. Oh, gotta get the technology to work right. So the measures of central tendency that we had spoken about was the mean, which was the big one that we'll probably discuss the most, but we also discussed the median and the mode. And we looked at how we can calculate that by hand and how our calculator can actually help support that. So make sure if you don't have it in front of you, you have your calculator with you, whether it's the Casio or the TI calculator. There is a lot in this particular lesson that requires that statistical analysis. So it says now we need a measure to compare how spread out the data is about the center, or how spread out your data actually is. So we're going to use the term standard deviation. This is a measure of the spread or the dispersion of the data. The lower the standard deviation, the closer to the middle the data is. The higher the standard deviation, so the greater value it is, the farther away from the middle the data is, or the more spread out it actually is. So we give the standard deviation the symbol sigma. So it looks kind of like that, kind of like a fancy O. So I'm just going to write it up here. So there is a calculation for standard deviation, but you're probably not going to have to touch it at any point because your calculator calculates out the standard deviation for you. So this isn't something you need to know, but I figure I'll just give you it. So standard deviation, again represented by sigma, is equal to the square root of the sum. So we've seen this before, haven't we? The sum of each individual data point, so we'll represent it with an X, subtract the mean. So remember the other day, the way that the calculator shows us mean is X with a line over it. So we take each of those and square it. So the difference between any particular data point and the mean, the square of that. And again, this symbol means the sum of all of those divided by n, which represents the number of values that we actually have in our data set. So we don't need to worry about this. Your calculator will do it for you. But again, it's looking at the difference between each data point and the mean. This is the big part of it. It's saying how far is each data point from the mean. If they're all really close to the mean, or the same number, you'll have a really low standard deviation. If your data is more spread out, you'll have a higher standard deviation. So that's what this portion of it is talking about. So I can hear you all groaning at this one already. So 2 potato chip companies have the following data about their products. So 2 potato chips, so we have Young Dutch, not to be confused with Old Dutch, because we don't want to get sued, right? And Dorquitos, not to be confused with Doritos. These are 2 totally fake potato chip companies. And so, so this must just be a small bag of potato chip. So we're given 2 pieces of information here. So again, X with the bar over it represents the mean. And again, the way that we get the mean, we calculated that out the other day, is you add up all of your data points and divide by your number of data points. So a bad way to say it is the average. We're going to use the word mean instead. And this again is the standard deviation. Represented by sigma here. So Young Dutch has a mean for its bags of chips of about 51 grams. So that's your overall, if you add it up, 100 bags of chips, the masses of them, and then divided by 100, you would get an overall mean of 51 grams. Whereas Dorquitos, if you did the same thing, you added up the masses of the 100 bags and divided it by 100, you get 53 grams. So overall, it looks like Dorquitos has the bigger bag, since it's a couple of grams more. But what we're kind of looking at with this one is the standard deviation. So as we mentioned kind of on that last page, standard deviation is a measure of the spread of the data. So if you have a low standard deviation, like we have here, we're comparing these two, this is a low standard deviation. The closer to the middle the data actually is. And if it's a higher one, the farther apart it is. So it says, which company has the more consistent product? So if we were to grab a random bag of Young Dutch chips, it's actually going to be more inconsistent. It'll have higher variability because this higher standard deviation means the data is more spread out, whereas this is saying it's more consistent. So you're going to be closer to 53 grams if you just grab a random bag out. So the more consistent product, again, would be Dorquitos. And again, that's because it has a lower standard deviation. I'm just going to write SD to save myself some time, but again, that's standard deviation. So the bags would be closer, would be a mass closer to the mean. So again, since this is a lower standard deviation, it means that the bags are all going to be closer to 53 than these bags will be to 51. So question B is kind of an opinion question. It says, which company would you purchase from? And so I probably would be like, oh, this has an overall higher mean, so if they're the same price, I'm going to get me some Dorquitos because they have an overall higher mean. But you could justify it the other way. You could say, maybe I'm going to get a Young Dutch one because since it's a little less inconsistent, maybe I have a chance of getting like a really huge bag of potato chips. But in that same breath, you could also say, I wouldn't get this Young Dutch because what if it's like a really small bag of potato chips? We've all opened those where you open up a bag of chips and there's like 4 chips at the bottom. It's very disappointing. So this is an opinion question. Okay, so the next one that we have here. So 2 math classes are given the same test, and their scores are shown below. So calculator steps. I have both calculators here so I can remember it. You need to do each separately. So in the TI calculators, again, sorry, I'm going to do this so I remember. So stat, edit. So you press the stat button, you go to edit, and then you enter class A into L1. And then you would press, sorry, so this is for the individuals that use the TI calculator. I'll do the Casio one after, so you can ignore this if you're a Casio person. So once you've entered them all into L1, then again you get back to your main screen, you press stat, you scroll over to calculate, and you press 1-bar stats, single variable stats. If you need to change that screen, if it's asking you about a frequency table, again, you just have L1, so you don't need anything in your frequency table portion. And then you press enter, and you will get those screens that have the mean, the sum of all the values, everything from there. So this is the TI instructions. Oops. Sorry, I'm just going to go back and scroll down here. So the Casio instructions, which I now need to kind of remember. So on your total main screen, your menu screen. You press that. And again, you're entering all of Class A into List 1. Again, if you had anything else in List 2, clear it all out. Once you've entered it all in, you press Calculate, which is your F2 button. Press 1 bar. If you've been doing something from a frequency table, at this point, remember you need to press that F6 or Set button and change your frequency list to 1, kind of like we saw the other day. So calculate F2, sorry, I'm doing this as I go, and then it gives you your whole screen, so with your mean at the top and then the sum of all of your data points. So this is how you get it for the Casio calculators. So what I was saying here is you need to do each separately. So you do Class A, get the data for it, and then erase Class A, and then do Class B. You can't do them at the same time. You need to do them one by one. So for Class A, sorry, you might have more room than me that you can write it over on this side of your sheet. That's where I have it written. I have it written over here. So when you do, sorry, if you want to, pause this and find out for Class A what is the mean and what is your standard deviation, then clear it all out and do Class B, mean, and standard deviation. So pause it for a second, do each of those, and then unpause it. So hopefully you've done it. Class A is 78 for the mean, and the standard deviation is 14.268. Class B, the mean is 78.4, and your standard deviation is 3.61. If you got different answers, maybe just go double check that you did them each one by one and that you didn't accidentally type 65 instead of 56 or something like that, because that's what those should be. So which class is more consistent? So which is closest to the mean? So we see the means are almost the same, right? 78 and 78.4. That's pretty close. So this has a little bit of a higher mean, but our standard deviations are what are significantly different. So this has a low standard deviation, and this has a higher standard deviation. And so as we mentioned before, the lower the standard deviation, the closer to the mean it is. So Class B has a lower standard deviation. So that means the data is closer to the mean. And we can see that from just looking at these. So the highest mark was 84, the lowest mark was 74. So they're all within 10% there. Whereas Class A, your highest mark is 94, your lowest mark is 56. So that's much more variable, right? They're spread out a lot more around that mean of 78 because there's a low mark here and a low mark here, but then there's also some really high marks. So question B is a little bit of an opinion question too. You'll find that this unit there are kind of some opinion and justification questions, but you need to justify it in a way that actually makes sense. Let me do that. Okay, so which class is more likely to receive a mark of 90? So my kind of opinion and my take on this is even though the mean is slightly higher, sorry, I'm off the edge of my tablet. For Class B, I would say that Class A probably is more likely. They also have one, so Class A is more likely because they are more variable. Oops, I wasn't looking at my screen. Hopefully you can read that. So even though the mean is slightly higher for Class B, Class A is more likely to get a 90, to receive a mark of 90, because they are more variable and they have marks farther from the mean. They're probably also more likely to get a 50 or something like that, right? So that's our indication of what standard deviation actually looks like. I just need to make sure I'm actually recording. Okay, good. Because that would be a waste if I wasn't. Okay, so on to the next one. So this is just giving us kind of some ideas of what graphs would actually look like, whether they're histograms or distributions, which we'll look at a little bit tomorrow. But it says, how would the graph change if the average was increased? So this is kind of a little bit hard to see, but this graph is just an overall distribution. This would be the mean. And then we see, like, this could be for heights of people, right? If the average height of somebody was, or the average height of a school was 180 centimeters, you'd have some people that are, or a lot of people that are close to that mean. And then you'd have people that are like way taller and way shorter, but there's fewer of those. So this is what this distribution is kind of representing. So it's saying, how would the graph change if the average was increased? Do stuff like this. So the average, I think we're kind of talking about the mean there if we're talking about the average. So if the mean was increased, we could make the mean right here. What the graph would look like if we increase the mean is it would just be shifted over to the right. So maybe that's if we go to a school that has a really good basketball program, overall their average mean might be a little bit higher because typically basketball players are taller people. So if it was a school that really focused on basketball, we would increase the mean and you'd probably have fewer-ish shorter people and you'd have more of those individuals that are taller as well. So how would the graph change if the standard deviation was increased? So I'm actually going to erase what I just did. I'm just trying to give you the visuals. So if I were to increase the standard deviation, so like we said before, a higher standard deviation means the data is more spread out. So if this is representing kind of the frequency or the number of people, what we would actually end up with is a graph that's shorter but wider. Because then data is more spread out. So we have more really short people and we have even more tall people. It's going to be more spread out about that mean. So the mean would still be the same for this, because it doesn't say we're changing our mean at all, but we're increasing the standard deviation, which would make our graph kind of flattened out and stretched out a little bit wider. So shorter at the mean, but wider overall. And if the standard deviation was increased, sorry, oops. So again, we're still going to have the same mean. So the mean is still here. But if we were to increase the standard deviation, it would actually be potentially, sorry, that's not a very good drawing on here. It's hard to write on my tablet. But it would be taller and thinner at or around the mean. So the mean is still the same as we had with our original one, but now we have more data grouped together closer to the mean. Oh, I can't write in red for very long. It's too stressful. Okay, so that's just graphically what it would represent. This is a long lesson. I'm sorry. Hopefully the rest won't be this long. And it's going to be a lot longer. So draw two graphs on the same grid that have the same average, but with two standard deviations. We just did this on the last page, so I'm not going to actually draw it. So it says for the curve with the lower standard deviation, the curve has a higher peak. So the curve will have a higher peak because there are more data points closer to the mean. So it says for the curve with the higher standard deviation, this curve will have a lower peak because the data is more spread out relative to the mean. So that should represent, graphically, you will kind of see some of these types of questions come up. Okay, so there's one more question in this part, and then it goes into that statistics booklet, and we'll talk more about French fries. So this one, it says from the table, determine the mean and the standard deviation. So this one's a little bit tricky. So it says gaming hours per week for grade 11 females. So how many hours per week are grade 11 females gaming? So it gives kind of a range. So it probably was some type of checklist, and they'd say you play between 3 and 5 hours, between 5 and 7, between 7 and 9, between 9 and 11, 11 and 13, 13 and 15. And you would just check off one of the boxes. So we see that 7 people gamed between 3 and 5 hours, 11 between 5 and 7, 16 between 7 and 9, 19 between 9 and 11, 12 between 11 and 13, and 5 between 13 and 15. So the little bit of a tricky thing with this, so we can use from our lesson last day that method number 2, right, where we're putting things into list 1 or L1 and L2, or list 2. But the hard thing is we can't put in 3 to 5. That's simply not a way. There's no way to put that into list 1. We can't write 3-5. So what I did for this one is I just put the middle value. So in list 1 I put 4, and then I put 6, 8, 10, 12, 14, and in list 2 I put the part that matched up. So 4 matched up with 7. So if you need to go back to that method 2 from yesterday, again, my Casio folks, hopefully you kind of wrote down or understood how to change it to the frequency distribution. So once you've put it into L1 and L2 from that stat menu, and you've pressed calculate, make sure you press that set button and change, so it says 1 var X list, should say list 1, and change 1 var frequency to list 2. You probably have it as a 1 right now, but you need to make sure that you change that to a list 2, and then change it back after, because it'll give you that weird error that we had. So we put all of this into the calculator, and then calculated it out. You can pause and make sure that you do this. And so hopefully you've had the chance to give it a try. If not, pause it and do it. So it says determine the mean and the standard deviation. So once you've put in your frequency table like this, calculated it out, you look for your mean. So again, that's that X bar, or X with the line on top. So the mean was 8.94, which should kind of make sense, right? That these are the two highest numbers. So it should be somewhere between like 7 and 11, kind of closest to 9 here. That does make sense. And the standard deviation, I can't remember if you have to scroll down to get to the standard deviation, but it shows that sigma, so make sure you're looking for that. So the standard deviation for this data set is 2.782. So that's all it's asking for with this one. All right, and we move on. What I'm actually going to do, guys, just because I'm nervous that this hasn't worked and I'm going to waste like an hour taping something that's not working, I'm going to split this lesson into 2 parts. You should do it all in one day, but just watch this video and then watch what I'll call part 2, which will be kind of the statistics booklet. So we'll flip on to part 2 right away here.